All right, good day, everyone. In today's lesson, we're going to be talking about transforming the absolute value of a parent function. Okay, so really the goal today is going to be talking about transformations. Basically, we're going to take a basic equation or what we call a parent function, and then we're going to add numbers to it, both on the outside and the inside. We're going to be adding, multiplying, dividing, all that stuff. We want to basically see how this changes a graph. Okay. The key thing you have to understand is that there is a specific pattern with transformations. Every single time we actually work these out, there's always going to be a specific pattern. Okay. With that pattern, we can actually determine how a graph is going to look without even having to actually graph it out. Okay. And that's kind of going to be one of the main things that we look at for today. But before we start this idea, before we start this concept, the first main thing we have to talk about is this whole concept of a parent function. Okay, this is a key term right here. A parent function is basically the beginning of a particular type of function. Okay. This would be like if I broke things down to the very basics of what they were, what would the original equation be? Okay. If I took all the numbers out, if I just had a set function. Now, there's a bunch of different parent functions out there. Okay. For example, like y equals x is a parent function. Y equals x squared is a parent function. Okay. They're similar, but you have to understand that each one is going to create a different graph. And then as I add numbers to those equations, it's going to change it. So we're going to be looking at a very particular parent function for today. Okay. To start this lesson, we have to understand what this graph actually looks like to actually start adjusting it. So we're going to look at the equation y equals the absolute value of x. Okay. Now, the key thing I want us to understand is as we do this, we want to go back and try to take our notions of absolute value and understand that an absolute value equation or anything that's taken to an absolute value basically can't become negative, nor can I have a negative as an answer, correct? That's kind of the whole point of this problem is that anything I plug in for this x should come out positive, right? That's truly what an absolute value does. So let's do a quick chart, graph this out, and just kind of see what it looks like. So if I do a quick X, Y chart, and I plug in the values -2, -1, 0, 1, and 2 into that equation up there, we want to know what happens. Well, if I plug -2 into the absolute value of X, my answer is just going to come out to be +2. So I'm going to go to -2, 2, plot a point. -1 plugged in the absolute value is just a +1. 0 is going to stay 0. And then when I plug a positive number into that value, there's going to be no change. So it's just going to stay positive. So we're going to have the point 1, 1 and 2, 2. And then we actually create this V-shaped graph built like this. Okay. Now, understand what's actually happening here. We have to kind of understand the absolute value of x function to really get the graph itself. Notice the graph, how it's just a V function where everything's pointing upwards. Okay. The reason it does this is because we've already talked about before how any value that goes into this absolute value can't be negative. So that's the main reason why there's no graph down here. Because I cannot have a negative answer coming out with that unless I act upon it in a different way. Right? So that's kind of the main thing we want you to understand. That is what the original looks like. And basically, when we do transformations, every single parent function is going to start off, well, I should say every single function is going to start off with that particular parent function. And then we're going to start building off it and trying to see like how do things adjust and everything like that. So down here we have 4 different problems. Now, for each one of these, Springboard book actually wants you to plug in the calculator. However, with me being right here, I don't really see a point to do that. Okay, let's actually just go through and start by on all 4 of these. Let's just plot the parent function. Okay, the same exact graph we had in the other one. Let's just draw that out. So the black lines are the parent function. Okay, it's the original absolute value function in all of these problems. So we'll draw 2 more down here. And then we'll start working up based off this information. Okay. Well, The black line is what's the old function, okay? This is just what we graphed up here, okay? The original function out of both of those. So the key thing we want to understand is how is this being affected, or what is changing based off this information? Okay, oops, I didn't graph one more. I gotta graph one more graph down here. So we'll start with the first one. We have the absolute value of x plus 1. Well, let's try to understand what's actually happening here. Let's do an x and y chart and actually compare our answers each time. So we would have, sorry about that. We'd have -2, -1, 0, 1, and 2. Okay? So the same exact chart as we have over here, but now I have to deal with this equation. So let's kind of think about how is this going to actually adjust. Well, if I were to plug -2 into that equation, absolute value of x plus 1, the absolute value of -2 would be 2, plus 1 would give me an answer of 3. So at -2, we would have 3. At -1, if I plug that in, I'd get an answer of 2. At 0, if I plug that in, I get an answer of +1. 1, I'd have 2, and then +2, I'd have 3. So notice what happened between this chart and this chart with all of my answers. Okay? I plugged the same x value in for all of those different values, and the only change was these y values right here. Okay? Notice how they changed by going up one value, right? All my y values just increased by 1. Well, the thing I want you to think about is look what happened in our chart as well. Everything increased, or all my coordinates that I originally have graphed went up one value. Okay? So I want to start making the assumption this technically works for all types of graphs. Okay? If I add or subtract values on the outside, it should move my graph up or down. Now, we're going to do the second one simply by just graphing it out and then checking it with a calculator. Okay? Well, if I graph out letter B here, the absolute value of x minus 2, I want to use that same logic we did in the first problem. If +1 on the outside makes it go up 1, then -2 should make it go down 2. So technically, all these coordinates should just go down 2 spots. And I should have my graph, which looks like this. Okay, that'd be the idea of that all those points are just going to drop down 2 spots because we're subtracting 2. Well, let's go ahead and check it. Let's go ahead and see if this actually works. So what I'm going to do is I'm going to pull up a calculator and actually plug this in. Okay? Because you know what? We did the graph on the first one. It takes some time. It takes a lot of work. Let's use technology to help us out here. Let's see if this graph actually comes out to be the way we want it to be. So we're going to go to our y equals here. Let's clean it up there. If you want to use the absolute value, you're going to hit alpha window. Once again, let me show this again. Alpha window. You can go to this first one that says ABS, which is just absolute value. So let's hit x minus 2. And let's see what it looks like. Notice how we have a starting point down here at -2, and we cross over at 0 when it reaches 2. Well, this graph is very similar to the other one we have. And if we want to get the same exact picture, let's just go ahead and plug in our parent function, alpha window, absolute value of x. So our parent function will be in red here. Notice how from the original, if red, the new origin drops down 2 points. So this is the same as what we have on the picture here. So we want to understand that there's actually certain things happening in this problem. Well, if I add or subtract a value on the outside of the graph, it's going to move it up or down. Okay. Now we'll talk about these other two right here in part 2, but there's one more we're going to talk about for today. Okay. We want to talk about what happens if I add or subtract numbers on the inside. Okay, we want to know if that changes the problem or not. So let's go ahead and graph our parent function once again. Our parent function looks like this. Well, what happens if we add 2 on the inside? Does this change the graph differently? Well, let's find out. We'll go ahead and build our chart of x's and y's. And then we're going to plug these values in, the same ones we've had before. Okay? In my head, I'm thinking, okay, this should look similar to what we had like right here, right? This should look similar to this part right here, where those numbers are pretty similar. It's just they move up or down very, very shallowly. But let's go and look at this one. If I were to plug these numbers in, let's try to think about what happens. If I were to plug -2 into this equation, this would be absolute value of -2 plus 2. Well, that's in the absolute value right now. And just to kind of clean up that other 2 right there. Technically, right now, this is all in the absolute value, right? So I would actually work this math out, and this would become the absolute value of 0, which is 0. So I went from -2 to 0, which means if I graph this, it's going to start -2. I go -2, 0. Okay, so let's keep going. Let's see what's happening. If I were to plug -1 into this problem, right, that went with my -2. If I were to plug -1, -1 plus 2, that would come out to be the absolute value of 1. That would just equal 1. So at -1, I'd have 1. Well, right now, it's really not doing much for me, because if I continue this pattern, 2 would give me 0, then 3, then 4. 3, then 4. But what's happening on the other side of that origin? I want to know what's happening over here. So let's just try one more quick point, because I want this V-shaped figure, right? So if I were to actually try the coordinate -3, and I work that out, I would get +1 as an answer. So at -3, +1. So what's actually happening here is this graph moved to the left 2 units. Okay? Notice how we started here, and now that same starting point's moved over to here. Well, this is where the interesting thing comes into play. If I have a value inside the absolute value point, it's going to move it left or right. However, it's always going to be the opposite value. So notice how if I have the absolute value of x plus 2, it moved it left 2 units from the original. Okay? Because a +2 is going to be in opposite motion. So what we have right now is we have basically a simple equation detailing out 2 different facts. All right, so I'm just going to write this out just so you have this. We have y equals the absolute value of x. Let's just say this is minus b. And on the outside, we have a plus c. Okay, those are the 2 different operations we could do. We could add or subtract on the outside, add or subtract on the inside. The b value makes it go left or right, but the key thing to understand is that it's always opposite. While the c value makes it go up or down. So if I'm thinking about these 2 equations here, if I were to see this, graph the function x minus 4 on the inside, I'm going to go to this equation and think, okay, it's on the inside. which means it's going to go left or right, and it's opposite. So minus 4 is going to go right 4 units. So that means my starting point, instead of being at 0, is going to be at 4. And I'm just going to draw my absolute value. And that would be the answer for that problem. For the letter B here, same thing. I'm going to look at this and say, well, what am I given? What can I use here? We have an x plus 5. We're going to use the same logic that we have, that it's always left and right, but it's opposite. So positive 5, because it's opposite, it's going to make it go left 5. So my starting point, instead of being at 0, is going to be at 5 now. So I'm going to draw my coordinate. And then my absolute value, which is just that V-shaped figure. Okay? And that's kind of the main purpose of today's lesson. Now, there's going to be more transformations at the end of this. We're going to be dealing with more overall. Okay, we're going to have something called a stretch and a shrink. And we also have to talk about what happens if there's a negative in front. But today we're going to talk about the basics of just how does a graph move based off the two values on the inside. Okay. Besides that, make sure you're answering the questions on the Ed puzzle, and I will see you in class tomorrow. Have a great day.